Welcome to the ROVE Tech Talk. SDN is it for my organization. I am Paul Campbell. I'll be your host today. I am the practice lead for software-defined architectures here at ROVE. My primary responsibilities revolve around everything software-defined, so we wanted to do one specifically on software-defined networking for everybody and kind of get the conversation started. Initial questions. So first off, we have what I refer to as the usual suspects. Aside from being a great movie, it prevents several routine questions. The first of which is software-defined networking. Is it just a buzzword? Oftentimes, we find that in our industry, new acronyms and new things come out that inundate our daily lives, and we are truly trying to determine whether or not this is the ship that we need to tie ourselves to. Do we need to go forward? Is this just a fad that's going to fade away? I would like to think and recommend that it is not just a buzzword. I think it is here to stay. And hopefully at the end of this session, if you are not currently exploring software-defined technologies, hopefully you will. So in the SDN space, there's a very large group of players, especially in the software-defined WAN space. You have to take into account what is going on with your organization. What are you trying to accomplish as a IT leader? What is the business trying to accomplish? The application admins have different goals, and the security team has goals, compliance, and all these things. So in the array of SDN players, which we'll talk a little bit more about later, you really have to determine which offering best suits your needs, your personnel, and your business goals. Another question that comes up is often that the SDN looks great, but not sure how my firm can appropriately learn and manage the technology. How difficult is it? This comes up routinely with software-defined networking, especially in legacy organizations that are contemplating making that jump when, maybe they haven't done a firmware refresh or hardware refresh in the last, 8 to 10 years. It's definitely a jump, but just like any new technology, imagine someone moving from Brocade switching to Cisco switching, or say a checkpoint to a Palo Alto or something like that. You always have to learn new technology. What I've found the most with software-defined networking is as long as you have a good base, a foundation in the networking realm, the adaptability and the ability for engineers to understand, learn, and evolve with the technology has been very positive. So let's take a look at how we got here. I'm going to jump into this phase that we call evolution. So when we first started, this is a diagram showing, how networks looked, 15, 20 years ago. We had many, many, many devices and many administrative domains. All these devices were managed independently. You had some chassis. You had daisy chains of switches. You had very segmented layer 3 cores and layer 2 cores. You had firewall edges. What ultimately ended up happening is that with spanning tree, as you continued around the complexity side, you ended up having more and more fault domains. So people tried to really segment their layer 2 core and layer 3 core. While this made sense back in the day, it doesn't make so much sense anymore, especially as we're starting to move away from spanning tree and a lot of new technologies. So what we're going to do through this process is talk also about, the backhauled internet, because we're not just talking about software-defined networking in the data center or just the campus or even just the WAN. We're going to talk about all of them. So one of these things that also happened a lot was very high-cost MPLS connectivity. People weren't really throwing internet at all their sites. They wanted centrally managed, centrally maintained internet boundaries. So everyone backhauled all their communication to the internet back to a centralized data center. Ultimately, that resulted in a higher cost, not only in the equipment, but also in the personnel. Think about an organization that has 1,000 devices that have to be individually managed versus centrally managed. So you have a higher cost of not only the people, but the equipment itself. So in the next section, we're talking about the collapsing of cores. So going back about, let's say it's 2017, let's go back about 8, 9 years ago. And a lot of people started delving into the collapsing of the core methodology. They wanted to say, let's get rid of this core and distribution area. You know, I still need to keep my access, so I have my accountability of end user ports and services, but I want to take that core distro model and let's collapse layer 2 and layer 3 while we're at it as well. So now you started having people go, you know what, I want to have fewer devices. I want to have significantly less administrative domains, so I'm able to manage more of my network with less people. Ultimately, especially after our economic downturn, that's what everyone's doing right now, and you know, do more with less. And as you do more with less, you ultimately make everything less complex. Now, as you can see from our first slide, a lot less devices, a lot less lines, all these things ultimately breed less complexity, which helps from a troubleshooting standpoint, an administrative overhead, and just simply a burden to the organization. We still had spanning tree in the collapsed core. Now, along with collapsing the core, we also started having switch stack technologies coming out through this process. You know, you had Cisco's stack switches, Brocade, Juniper, all these guys started throwing out stacks of switches because not everyone had the ability or cost up front to buy, you know, modular chassis that were fixed and blades. They wanted to grow independently and scale as they needed. So that really helped with the continual collapsing of the cores as well. Now, you know, in this scenario, we started also having people say, you know, I want to bring my internet, I don't want to backhaul it anymore. I want to try and save a little bit of money, not necessarily throw it over MPLS. Or maybe they did want to put internet, but they wanted to provide an internet DMVPN so that way they didn't have 2 high-cost MPLS circuits. So we started seeing internet DMVPNs popping up all over the industry. Individuals started finding that, you know, there's inherent security challenges and concerns that they have with that. So the technology started evolving. You know, we went from DMVPN phase 1, 2, 3. You know, IPsec saw some enhancements as well, and everyone started moving forward. This resulted in a reduced cost to the equipment that people were buying because they were buying less of it. And just like anything else in technology, the latest and greatest is always able to do more in terms of, you know, routing, switching, and everything like that, but usually at a smaller cost. While it may be, say, a 10% more expensive switch, it gets you a lot more throughput and bandwidth than the previous model. So next we started delving into fabrics. So as you see, everything here I did in bubbles for the fabrics. Now note that it doesn't necessarily mean that there are less devices. In fact, it's a very similar device count. So with the fabrics themselves, you started having administrative domains that allowed you to manage things independently without having to touch all the devices, which you still had to do in the collapsed core area. Now, I know some people out there may be thinking, you know, you could have used Cisco Prime, SolarWinds Config Editor, IBM Tivoli, any of these guys to administer your environment and make it less hectic. That is absolutely true. What we're talking about here are inherently built-in mechanisms by the manufacturer who was providing the solution to begin with. Now, with these fabrics, the ultimate goal of a fabric was to ultimately make it less complex and remove spanning tree. Everyone has a love and hate relationship with spanning tree, I have seen over the years. It is a necessary evil for a very, very long time. However, as we continue to move forward, its necessity is becoming less and less prevalent in the world of modern and next generation networking. So in the intent of the fabrics, you know, you had Cisco Fabric Path came out on the initial Nexus lines. You had Arista's scale-out fabric. You had Brocade's VCS. Juniper's Q fabric. All these technologies came out with the intent to centrally manage and remove spanning tree. Specifically in the case of fabric path, everything started routing based on switch ID tags. And this allowed you to have a very low latent layer 2 connectivity. Well, the same thing started happening on the campus side. However, the only real person who built a campus fabric at that time was Brocade. Their VCS solution could be used in the data center or the campus. The reason that people didn't really adopt Q fabric or Cisco's fabric path was because it was just too expensive for a campus. It made more sense in a data center. Now, from a cost perspective, it's a similar cost to the previous model. In some respects, you're doing a little less device count, but things did see a little bit of an uptick in the market on how much everything was really costing. And similar to personnel, you know, you're dealing with a newer technology. You're going to need to have personnel that can learn it, understand it, and support your organization as you continue to move forward. So now while we're here, so what happened is software-defined networking really started making a big shift in the industry, allowing for even less devices than before and significantly fewer administrative domains. It brought about simplicity. Everything was GUI-driven, spanning trees still removed, and in the case of the WAN, MPLS reduction costs went down, which ultimately resulted in a lower cost for equipment. And to highlight everything, in the data center, for example, you have VMware NSX, Cisco ACI, and these things really started allowing integrations with the other devices that are around them. In the WAN side, you started having the mentality of, well, we still want to use internet tunnels, but managing these internet tunnels, especially in an organization that has, say, 600, 700, maybe 2,000 remote sites, gets to be a pretty large burden and overhead. MPLS connectivity also for those sites can get really expensive, and especially if you're in a heavy merger and acquisition firm, then waiting for an MPLS circuit to spin up is not always ideal. So what a lot of people started doing was saying, we need to find a way, and this was done by many companies, is find a way to simplify the WAN. Let's aggregate the internet and MPLS, and let's have these individuals be completely agnostic. And that's probably the number one thing about SDN, is a lot of things are agnostic to the underlying infrastructure that you're riding across. Now, you will have some inherent things that have to be done, like Cisco Nexus 9000s for ACI, VMware for UCF, and things like that. And, IWAN, Cisco IWAN requires ISR, ASR routers. You have products like Citrix, NetScaler, SD-WAN, CloudGenix, all these things. Some can be virtual, some can be physical. But the point is that in the SD-WAN space, it doesn't matter to me what the underlying architecture is that gets a packet from point A to point B. I'm going to spin up either an IPsec tunnel or a proprietary protocol, depending on the vendor, and build this mesh network. And it doesn't matter to the user or the admin necessarily whether or not they're using internet or MPLS, as long as they're getting the security and the mechanisms that they need. So with the increased security, you also start delving into user application and visibility that you didn't have previously. A lot of organizations, have a firewall, and they think that they have a lot of user and app visibility, and some do, but a lot are lacking. I can tell you myself, when I worked at a large cable MSO, oftentimes understanding how apps worked and who was using them and other things that delved beyond the realm of networking was something that I never had access to. And the company itself also lacked a lot of visibility in that regard. And lastly, with SDN, you get a lot of analytics. You have the ability to aggregate data through this GUI, through everything that is constantly talking across a control plane, that allows you to aggregate the information and go back in time and look at data, but also allows you to understand who's using your network when, allows you to make better decisions for the company, and ultimately just provides a slew of content that you didn't have previously. So the benefits of SDN, we highlighted a few on the previous slide, but these are some that I think I wanted to have a little more breakout on. So we have a segmented control and forwarding plane. Now for non-technical people on the call, doesn't mean much. Ultimately, think of it this way. You have the ability to forward packets, route packets, do all of the normal packet switching and handling on these devices in an SDN network. Meanwhile, the brains and the control, the programming capabilities and all these things are handled by a centralized controller. Now, depending on your solution that you go with, the controller has to be up all the time, and if the controller goes down, forwarding stops. In others, the controller can go down and forwarding doesn't stop. Some have mechanisms to allow for up to, say, 24 or 48 hours of traffic passing, some don't. Now, that segmentation is great, but what can we do with it? So with that, we get the visibility we discussed. Your network effectively becomes a network-wide intrusion detection system, depending on the product and solution that you choose. Also allows you to dig deeper with the forensics. You can almost fingerprint individuals across the network. You can fingerprint applications. You can understand if an individual application is being honed in on versus another from a security perspective. You're able to provide significantly more data to an internal security compliance team or another operations team. Self-healing adaptability, aside from being a little bit of a buzzword, is that all networks for the last several years should all be built with redundancy and protocols in place to handle failovers. The difference with self-healing adaptability is that you're not really going in and then configuring HSRP, VRRP, GLBP, spanning tree, all these things that you had to manually do to ensure that your network didn't have any faults that rendered it useless. In an SDN network, these things are accounted for you internally within the mechanisms of the product, so that way you do not have to do this manually, which is a huge benefit to an industry that is sometimes lacking in extreme level, say, QoS experts at every organization. Lastly is application-specific routing. So long are the days that we turn around and route everything based on IP addresses. The world is shifting towards application-specific needs and necessities. I bet most people on this call or watching this video have an iPhone or an Android or some kind of smartphone, and everything you have is an app, and if that app doesn't work, you find another app that will work. That is the same thing for us as a consumer and also for our customers when they themselves have consumers trying to access their equipment. So likewise, internally, you need to make sure that your specific applications are being handled appropriately beyond the mechanisms of just QoS. You know, imagine an internal ERP system that you're doing analytics on a per packet basis that allows you to determine whether or not it's a good or poor performing application, and then handle it appropriately across a myriad of links to ensure that the end customer experience is at the level it needs to be. Secure communication between endpoints is the next highlight of SDN, especially in the data center where you have end-to-end communication taking place east-west. Traditionally, a lot of people are not firewalling off every segment in their data center. So they have to sit there and say, how can I protect my environment from my environment? Because most of the attacks when people get in aren't trying to bust all these different public-facing IP addresses. If they get in, they want to get in and spread around. So you're now encapsulating and encrypting communications between endpoints across the network so that host A and host B are communicating only when you allow them to. Inherently, in the data center, most SDN solutions are a whitelist model. And then as far as it goes for the software-defined WAN, a lot of people say, well, hey, I don't want to send my company's proprietary information or other stuff across an internet VPN, I don't trust it. Well, and there's different forms of SD-WAN offerings. Some allow for cyclic rotation of IPsec keys or various keys of any kind, as often as every 5 minutes or a minute. Others you can manually configure and roll out, but the point is that you have a way to now control the security on your WAN in a much more broad sense. I would imagine that there may be organizations out there that have WAN IPsec tunnels that they may not have changed the password on even after personnel have left. So that is a security vulnerability. SDN also provides an intelligent network with northbound and southbound APIs. The highlight here is that when you leverage an SD-WAN, an SDN solution, especially in the data center and soon in the campus, you should have integration with other environments. Imagine a world where you provision a VM or a container and allows you to then update the SDN component that is managing the data center, and then turns around and updates the firewall policy, updates a load balancer, updates these things that your company has proven is allowed and matches the company standard. Now you no longer have to submit a firewall request, a network request, a load balancer request, and a slew of others. It makes it entirely more beneficial for your organization to expediently roll out new applications and offerings for your customers. Automation and orchestration is built in to the product. There are tools and other things out there that can help further automate and orchestrate any SDN solution, or it can be homegrown, with your own developers on staff. The main thing to highlight here is just that a good SDN has a lot of this built in for you. Now, does it mean that you can leverage the SDN solution to go and automate other things? Probably not, but at least for its own internal administration and management, it is typically built in. Zero-touch deployment. So I have the word variable here so that I can highlight that not every SDN is zero-touch deployment. There are a lot that have them. So, for example, in the SD-WAN space, almost every one of the big major players offers some form of zero-touch deployment, zero-touch provisioning, however they want to give it an acronym. Likewise, in the data center, you have the same concepts as well, where the goal here is that as long as you have a central manager up the control plane, connecting to the forwarding plane device to configure and administer should require the least amount of remote hands possible if you yourself cannot get out there. And we wrap up the benefits with the reduced complexity and the single pane of glass management. Like I said a few times throughout this, every SDN solution should come with a really good way to manage it, all through a GUI that requires little to no, in most cases, hands-on CLI with the equipment. The benefit to this is that you can, say, bring in a new engineer to your organization to specifically administer and manage net new software-defined networks. This individual would probably not have any preconceived notions of how to manage things on the CLI. That can be a benefit and also a con. Likewise, your legacy individuals have to learn the new technology, and I myself used to be a big CLI advocate. I've moved towards the GUI myself, and the one thing I can say to everyone who's listening is that your inherent knowledge and expertise around troubleshooting networks and how they function does not go away just because you move to a software-defined network. It actually makes you more valuable because now you can provide things and troubleshoot and think outside the box. And ultimately, at the end of the day, underneath software-defined networking is still regular networking, just with extra bells and whistles to make it easier. So SDN considerations. The thing I want to highlight here is, let's just go through a few things to consider when you're looking at SDN. Who's going to administer the deployments? Is it your existing personnel? Is it a new team? Is it repurposed individuals on staff? Something like that. New technology requires learning, but what's the curve? Like I said, all new technology does require learning in some way or some sense or fashion. However, between a good partner, between a good manufacturer, and other things, the training that I have seen required to get an SDN network off the ground has been minimal and easy to be achieved. But at the end of the day, you do also have to take ownership of your network. ROVE or any other partner can only do so much in terms of being there with you every day. We want to make sure that our customers have an environment that they can administer and manage long term. And, I think that's the goal of any good partner. Also with SDN is purchases. Is there a refresh cycle coming? Are you investing in white box customization, or are you going to buy a standard SDN like Cisco ACI or VMware NSX? Are you investing in a virtual SDN implementation, or does your selection require physical equipment? So, for example, are you looking at Cisco IWAN wanting to do ASR and ISR routers? Are you looking at, say, a Citrix NetScaler SD-WAN or a CloudGenix or Viptela, and you want to do virtual boxes or maybe their own white boxes? There's a lot of things to take into account there. But SDN, just like anything else, is the solution that you do need to spend a few dollars on, and usually refresh cycles is where that comes into play. So lastly is, are you going to leverage multiple technology verticals? One of the biggest things about SDN, especially in the data center, is its interaction with other vendors and products and solutions, allowing you to bring firewalls, load balancers, and these things together to operate as a single intelligent network. So we'll end with SDN. Is it for my organization? So what I would like to position for everyone is about 5 questions. First is, how difficult is my network infrastructure to manage today? Ponder that. Think about how many times you have outages or issues caused by human error, policies, procedures, and things like that, where automation or other concepts can help centralized management, et cetera. Does my current network provide the application visibility the company is looking to acquire? Like I said, moving towards application-specific handling allows many organizations to focus on what is more of their bread and butter and what's more benefit. A lot of legacy networks cannot provide the visibility that a lot of corporations, CTOs, CIOs, CMOs, et cetera, are looking for. Do we have any security initiatives on the horizon? This could be PCI, HIPAA, et cetera. Ultimately, an SDN is inherently compliant with a lot of different things. For example, Cisco ACI works diligently with PCI, PCI DSS, HIPAA, and several others to certify, as long as you hit a few specific checkboxes, your infrastructure is compliant. This is a big thing going forward. Have we explored the cost savings analysis SDN can bring? This is specifically around the SDN WAN offerings, allowing you to cut off high-cost MPLS circuits while providing low-cost commodity internet links with higher throughput and 5/9 uptime is great. Saves a lot of people money, and that can then be repurposed towards other IT initiatives and business objectives. And then lastly, which SDN would benefit my company the most? We talked about SDN in the data center, where you have VMware NSX, Cisco ACI, Arista software-driven cloud networking, Brocade VCS, Juniper Contrail. All these things are out there. Which one benefits your company the most? In the WAN side, we have Cisco Intelligent WAN. Cisco just recently acquired Viptela. Citrix NetScaler SD-WAN, Meraki, SD-WAN, CloudGenix, Silverpeak, Riverbed, StillConnect. There's so many in the WAN space, but which one suits your needs for what you're trying to accomplish? And then in the campus, Cisco has an SDA solution coming out, being announced at Cisco Live in Las Vegas this year. So excited to talk about that. I'm sure we'll probably do another tech talk on that specific one. But with that said, myself and our practice lead for collaboration will be out at Cisco Live 2017. So if you would like to reach out and contact us at info@withrove.com, we can get something set up. Would love to meet and greet and talk to anyone out at Cisco Live. And ultimately, I'm very happy with everyone who attended today. I thank everyone for their time. And, you know, I hope everyone got something out of it. And just feel free to reach out to info@with-ROVE. Well, thank you, everyone. I hope you enjoyed it. And thank you for joining, and stay tuned for more Tech Talks coming out in the future. Have a good one.